going to discuss projectile motion, and we are going to cover these topics: equation of path of a projectile, and time of maximum height, and time of flight, and maximum height of a projectile, and horizontal range. So let's start. Let's say there is a body, and this body is thrown with some initial velocity v naught, and this velocity v naught is making an angle theta with horizontal. So let's say this is horizontal, and this is theta, and then this axis will be vertical axis. Let's say this is y axis. So unit vector along this x axis or horizontal axis is I cap, and unit vector along this axis is j cap. Now this body will go, and then after reaching some maximum height, it will start descending, and then it will reach to the ground again. So this kind of motion is called projectile motion. What is happening here? So a body is thrown vertically, uh, making some angle theta with horizontal, and then this body follows some path, and then it comes back to the, let's say, same level. This motion is in plane, vertical plane. Here we are taking the plane to be vertical. So this motion is in vertical plane. The body is called projectile, and its motion is called projectile motion. And the path followed by this projectile is called trajectory. And then we have certain maximum height here, that is the body is going upward, vertically upward direction, and to reaching some maximum level, it will start descending from there, and that height up to where it goes is called maximum height. So let's say it is h max, or sometimes we denote it by capital H. Meanwhile, this body travels some horizontal distance also. Let's say this distance is r. So this is called range. So this motion is called projectile motion. This motion is happening in a plane, the plane which is a vertical plane to the ground. And here there is one more thing. This body is under influence of acceleration due to gravity only. The only acceleration this body is facing is acceleration due to gravity. We are neglecting air drag or any other force causing some acceleration to the body. We are neglecting those things. We are including only acceleration due to gravity, which is always vertically downward. That is, if we want to write acceleration due to gravity with its unit vector, this should be minus j cap, because vertically upward we are taking unit vector to be j cap. So vertically downward it should be minus j cap. So let's start one by one. First, we are going to resolve its motion into two one-dimensional motion. So this is a motion in plane, but to study this motion, we can make it simple by resolving into two independent one-dimensional motion. So how can we do that? Let's say we are resolving this along x-axis and y-axis. So along x-axis, let me redraw this thing. This is initial velocity v naught, and this angle is theta. So along x-axis, the component of initial velocity, let's say v naught x, is v naught cos theta, and along y-axis, the component is v naught y equals to v naught sin theta. We can see here very clear. So this is v naught along y-axis, and this is v naught along x-axis. So we can write this way. Now acceleration. So acceleration along x-axis is 0. There is no horizontal acceleration. Let's not write for a unit for some time. We can use a unit accordingly. And this ay is nothing but minus g j cap. Here acceleration is constant. This acceleration is vertically downward all the time during the motion. Then at any point of time t, let's say at any point of time t, its velocity will be, let's say vx, at any point of time t will be V naught cos theta, and Vy will be V naught y minus gt, or V naught sin theta minus gt. And at any point of time t, the horizontal displacement xt will be V naught cos theta into t, and vertical displacement y t will be ut plus half at square. So here u is means initial velocity along y axis is V naught sin theta into t plus half at square, but here a is negative g actually. So minus 1 by 2 g t square. So we have resolved the velocity, acceleration, and displacement along x-axis and along y-axis. From here we can get the equation of trajectory, equation of its path. So how can we get? Let's say one more thing here. In our previous equation of xt and yt, we had x naught term here and we had y naught term here. We have already discussed about these equations in previous videos. So here in this case, we have taken this x naught and y naught to be 0. It means we have taken the starting position of the body to be origin. So we are not writing these terms here. Okay, let's move to next point. So y of t equals to v naught sine theta and into t. So from here we can say this t equals to x of t. Let's write only x divided by v naught cos theta. So here we can write v naught sin theta t into v naught sin theta into t equals to this much, and then minus 1 by 2 g and x minus v naught cos theta whole square. Or we can simplify it further. This will be tan theta, this v naught and v naught will cancel out, and then sin theta by cos theta will be tan theta. So it will be x into tan theta minus 1 by 2 g x divided by v naught cos theta whole square. So this is the equation of trajectory of the projectile. Now we can see here, this is x and here a square term. So this will be x square. So this equation is a kind of quadratic equation. So the trajectory should be parabolic in nature. So this is the first thing. Let's check. Yes, equation of path of a projectile. And then this path should be, based on that equation, we can say this path should be parabolic in nature. Now moving to next point, time of maximum height and time of flight. So how can we get that thing? Okay, time of maximum height. Just look at this equation. Here we have Vy equals to V naught y minus g t. And at maximum height, this should be 0, because after reaching maximum height, there should be 0 vertical motion, because if there is some vertical component of velocity, it will go up and up. Let's start from here. If this body is going upward, then the point at which its velocity is 0 is the maximum height. From here it will start coming down. So we can put this thing, and then we will have v equals to v naught sin theta minus gt, and this t is now v naught sin theta by g. So this time will be the time of flight, or sorry, time of ascent, and then we can say time of maximum height, whatever you want to call it. And then after reaching maximum height, when this body start descending downward, it will take the same time to reach at the same level. So if we want to know what is time of flight, so time of flight is nothing but the time of ascent and the time of descent. Then these two times are equal. So this will be, sorry, here g should be there, 2 v naught sin theta by g. This is time of flight, means the time during which the projectile is in air. Now moving to the next point. Okay, maximum height. So once again, let's say this is time of ascent, and we can write y equals to ut, u is nothing but v naught sine theta, into t, that is v naught sine theta by g minus half g t square. Why I am writing v naught sine theta by g in place of t here? Because this is time of ascent, means time to reach the maximum height. So if we are putting this time in equation of y, we can get the maximum height up to which this projectile is reaching. So we can solve this thing. This will be v naught square sine square theta by g minus uh, v naught square sine square theta by 2g, and ultimately it should come v naught square sine square theta divided by this one will be 2 minus 1, and then there should be 2z. So this is the maximum height attained by the body. Okay. The next point is horizontal range of projectile. So horizontal range we can find out x equals to ut minus ut plus half at square, but here there is no acceleration, so we can write simply uh, v naught cos theta t into time of flight. So this is the velocity along horizontal, v naught cos theta t, and with this velocity, if the body travels some distance for time tf, which is time of flight. Why I am taking time of flight? Because look, this body will be covering the horizontal distance as long as it is in the air. Once it reaches the ground, it will stop there. Let's say for a moment we are choosing this way. So this is the range, and now we have already found out this thing. So v naught cos theta t and time of flight, we have derived expression for time of flight. This is 2 v naught sin theta t by g. So here will be 2 v naught sin theta and divided by g. So this is, now we can write v naught square, and there will be 2 sin theta into cos theta divided by g, and then we can write range equals to v naught square, and 2 sin theta cos theta is sin 2 theta divided by g. This is the range, and as we know, sin x has maximum value of 1, that is sin 2 theta has maximum value of 1, that is sin 2 theta has maximum value when it is equal to sin 90, or we can say theta equals to 45 degree. Why I have done this thing? This is the condition for maximum range. So what should be the, for a particular velocity, what should be the angle of projection uh, to reach maximum range, to get maximum range by the projectile? So this is the angle, 45 degree. So we can write R maximum will be v naught square by g, because sin 2 theta should be 1 for the maximum value of this term. So up to here we are leaving for now. Next we will discuss about circular motion, and maybe we can solve some examples related to projectile motion.